Okay, and now I will share screen. And here we go. Hey, everybody, and welcome to this special presentation. This is welcome to the Tampa Bay Data Engineers Group. It's the final meeting of the year. So again, if you haven't joined the Meetup group, do join the Meetup group so that we can find out about future events. Other great Florida meetup groups also that do virtual talks. There's also the Orlando Data Engineers meetup group. So join all the meetup groups, find out about all the great data events going on in Florida. And if you're not from Florida, thank you for joining us for this special virtual presentation. My name is Alex Merced, and I'm going to be doing this talk, Zero ETL. So immediately when we hear that, it's like Zero ETL, meaning like not move the data. Well, we'll get there. And virtual data marts. So data marts built on logical views, so no duplicate data. How's that going to work? Well, we'll answer that question by the end of this presentation. Okay, but we're going to be talking about the cutting edge of lakehouse architecture, and we'll see sort of how can we make this possible? How is it possible? How does it work? And what are the benefits of it? But again, who am I? My name is Alex Merced. I'm a developer advocate for Dremio. I've worked in the web and data spaces for many years. Have worked as a developer for companies like GenEd Systems, Crossfield Digital, Campus Guard, General Assembly. I'm also the co-author of the upcoming Apache Iceberg, the Definitive Guide. Have spoken at many events like Data Day Texas, which I'll be speaking at again next month, OSACon, which I'll be speaking at again next week, P99 Conf, Data Council. Um, just love technology. So I love talking about web and data. So I have several podcasts where I do just that, along with just like enjoying writing libraries and writing like useful utility libraries in Python and in JavaScript and whatnot to help with sort of different data and web work. So I love tech, and I love talking about tech. But again, I on that whole idea of talking about tech, I basically host several podcasts, which you can subscribe to on Spotify and iTunes, including all the following you see on the screen, which includes Gnarly Data Waves, In the Grand Scheme of Things, Data Nation, and Select Star from Data Lake. I'll be having some new episodes coming out next week. So good times. But now, with no further ado, let's kind of get into the vision. So that kind of understand sort of like the why I would want zero ETL and virtual data marts and what these things are going to mean. We have to kind of understand how sort of and make sure we're all on the same page of sort of how things are being done today. So sort of like what is the state of the data engineering world today? Okay. Oh, wrong direction. There we go. Okay. So bottom line is you have your data sources. So maybe it's an application. So let's say something like a Facebook. You have several databases that are storing user data for operational purposes, typically in sort of more of a row-based format, which is great for transactional type transactions. But you now want to start doing analytics. Okay. And you don't want all your analytical work going to the same database as your operational work. Okay. Because then they're using up those same resources and competing for those resources. Also, analytical work works better in places that handle things in a more columnar format. So we want to kind of take that data and move it into other systems that are more optimized for our analytical use cases and that doesn't interfere with our systems for operational use cases. Okay, so we generally will begin to export that data, the E. Then we'll make some changes, denormalize some data, dedupe some data. We'll transform, and then we're going to load it or land it in a destination, which typically at first is our data lake. So our data lake, which is going to be this big place where we're going to store all of our data, whether they're structured and have columns and rows or unstructured audio files, emails, logs, all sorts of things. So all the data is just going to get put onto the data lake where we can do things when we want to. But oftentimes people like the feel of a database, right? So we like using our Postgres's and our MySQLs and our SQL servers and being able to send SQL. We just kind of want a system that's more optimized for this type of analytics. So this is where data warehouse platforms come in, where they kind of offer you these sort of big database-like platforms, except they're geared towards analytics or optimized for analytics, but they take the SQL, they give you sort of like the nice interface to manage all these things. So then we're going to take some of that data that's sort of our priority data for analytics and move it into a data warehouse. Not all the data, because that gets expensive, because you now have a copy of the data stored in the data warehouse, and you're paying for that storage of that data on top of all the compute for querying that data. So, and again, all these pipelines are not simple. It's not like, hey, just move A to B. Oftentimes you might move A to B, then B to C, then C to D. Okay. But then also you end up at E, and then E and D have to be done before you go to F. So this is where you start needing like orchestration tools to help keep the order of all these things straight. So you're
Hey,
designing each individual sort of step in this whole journey.
sorry
And
to interrupt you, Alex. Can I say something?
sure, go
Yeah.
for it.
So I just wanted to, when you said you have to pay for storage, you mean like a subscription, like when you on the cloud, you mean, right? For like a
Uh,
Snowflake of the world and stuff like that, where
well,
you,
it can depend. It depends whether it's an on-prem data warehouse or in the cloud warehouse. So if you're talking about like maybe an old school Teradata, you're buying, you're
yeah, yeah,
buying the actual physical nodes, which storage and compute. So it's all coupled together
right.
versus using something like cloud where you're paying for them separately.
Yeah, no,
Um,
but the thing in terms of uh, cloud is that uh, if you don't do your housekeeping, you end up paying for your storage, even though you know the storage is not getting used.
100% agreed, and that's exactly one of the problems we're going to be talking about today. So, well, yeah, so that's exactly right. We'll move data into the data warehouse, and again, you're paying for all that storage, and that bill can get really expensive. Not just because
Yeah.
the
I
data
mean,
you're
if
running.
somebody doesn't, I have customers who, pay through their nose just because they don't have somebody who does the housekeeping for them.
100%. So it would be, um, and again, I will get into a lot of that housekeeping and a lot of the ways where these bills explode later on. But with that,
Sorry, I didn't mean to interrupt. I thought it was a good point to
oh
interject and,
yeah, not a problem.
my 2 cents on this.
No, it's not a problem. It's all good. We're here to have a conversation, so I appreciate that. It's all good. But yeah, so you were basically going to be spending money in these data warehouses on top of what you're already spending for the copy of the data you just made in your data lake. So you're paying you're paying for wherever you stored your data lake, you're paying for the data stored in the data warehouse. And oftentimes that cost is going to run amok for a variety of different reasons. Part of it is you might be keeping track of historical versions of the data which you may not be using, or other data that you may not be using that you did at some point in the past. It just ends up exploding. But once we get all this data where we land it, so again, we take the data from our operational data sources, we move it into our data lake where we're just going to have all of our data, then we move it some of it into our data warehouse for analytics. We then use that to kind of feed BI dashboards, data applications, and so forth. But again, take a look at all these squiggly lines. This represents all those complex pipelines you have to write and orchestrate and deploy and test. It's a lot. Okay. And then even then, you're still going to be taking a lot of that data from the data lake and working directly from the data lake. So the thought process becomes, wouldn't it just be simpler if I could just done more of that work directly from the data lake, directly from that big structured and unstructured storage? Yeah, that'd be great. Okay. Because I have lots of problems with this current setup. Okay. I mean, oftentimes there's so many different pipelines going all over the place. There might be, they might break or they might be working, but now I have to, there's a request to add a table, add a column, remove a column from a particular schema. So then I got to change that pipeline to add that column. But then I got to make sure I adjust all the pipelines that lead into, or all the upstream and downstream pipelines to make sure that they're all in sync. If not, then you causes like breakages, which means I have to go back and like repair the data. So I'm backfilling for the whole weekend. It can be really, really tedious. Like it's painful. And again, that time that's lost is time that you're not working on other things, creating access to new reaches of data, and expanding the usage of that data, because
And
you're
then-
just
and and I'll add on to that, especially when you're writing pipelines in just plain SQL or DBT kind of stuff, it just becomes harder and harder.
it gets quite complicated because you're creating layers and layers. I mean, DBT definitely can possibly make things easier, but at the end of the day, it still becomes so many layers after a while, and it becomes real painful. And then basically, what happens there? Okay, well, basically, you have two problems. One, if things break, well, that slows things down. And two, if you have so many different pipelines, if it goes from A to B to C, the D, the E, the F, the G, the H, so all these different jobs have to run before the data is even available to the end user. Well, they're going to get upset because they're not meeting their SLA, so that way they can have the data they need to make decisions in a timely manner. And if anything breaks along the way, that data could be inconsistent, and they could be making the wrong decisions based on that data. So there's a lot that can go wrong. So the hope is to kind of, well, it would be nice to avoid all that. And on top of it, it's just all the costs, right? Because basically we have all the things that make our life as a data engineer a little bit more, but then also the costs, which include storage costs, as we mentioned earlier. So I'm paying for that data lake storage, I'm paying for that data warehouse storage, and then a lot of times people don't realize it, that every time they update the data, there's historical versions being tracked by different data warehouses, and then you're paying for the storage of those historical versions, and that can add up over time if you're not maintaining them. Okay, there's compute processing costs. Okay, you're paying for that every time you move the data, every time you make a copy of the data. You are, especially if you're doing this in the cloud, you're spinning up a compute instance, and you're paying for the time that that compute is running, and that can add up if you're doing the more of these jobs that there are. Then the thing that always sneaks up on everybody is like egress costs. People know that, okay, I have to pay for the compute, I have to pay for the storage, but they don't realize that generally when you're moving data between regions of a cloud, or you're moving data outside of a cloud, so you're moving it outside of whatever cloud to your X warehouse, well, there's also a fee for moving that data out. So if you're frequently moving this data out of your cloud and transforming it and landing it somewhere else, that you're going to end up having all these egress fees that add to your bill. Okay, on top of it, all the time lost, because you're maintaining all of just maintaining this big web of pipelines and and chains of things. And then also if you're in a heavily regulated industry like finance or healthcare, where you have to worry about masking things like PII and other sensitive pieces of information, well, having all these copies, you might accidentally have one where the data is exposed, and now you're running risk of regulatory fees when you get audited. Okay, data model drift. The more copies of the data, the more chances that the schema of those copies begin drifting from the original data model, which can affect training AI models and things. And then the cost of those bad insights, if the data isn't consistent. So there's all these compounding costs on top of the difficulties and stress of dealing sort of with the common paradigm, which is why there's such a huge sort of gold rush right now, and just tools that are trying to make this whole thing easier. Okay, but it's not just about making it easier. Okay, ideally you shouldn't have to do a lot of these things if you don't have to. Okay, what's easier than just not having to create thousands of pipelines? Okay, so like dbt makes things a lot easier by orchestrating and allowing you sort of have giving you a declarative way of expressing what you want, but you're still making copies along the way, and you still have those issues of like data drift and physical storage costs and whatnot. Now Dremio, what we try to do is we try to take a different approach. The idea is zero ETL, meaning we want to minimize the number of manual data movements. So basically the whole idea behind all of this is just reducing the amount of things you have to do manually. Okay, so the less pipelines you have to write, that's the less pipelines that can break, the less pipelines you have to maintain, deploy, test, and then you have that's going to free you up more time to focus on the modeling side of things. Because at the end of the day, you still got to design those models, figure out, hey, well, how am I going to design the modeling of this data to provide the most self-service experience possible? Okay, where people can kind of really understand the data that's there, what does it mean, its semantics, all those things. So we really want to kind of free up the data management aspects of it, so that way you can focus on the modeling aspects of it. So typically the idea here is that you would just connect your data sources to Dremio. And Dremio can connect to many sources. It can connect to data lakes, databases, and data warehouses. So there's different ways people will use this. Some people will connect directly to their databases and say, hey, you know what? I have a SQL server. I'm just going to connect directly to that SQL server and then use Dremio right on top of that, and kind of create that data warehouse feel right on top of my existing SQL server. And again, how to do that at scale, I will get to, because I know probably thinking is like, wait a second, there's a couple of scaling considerations in doing that. Other customers, what they'll do is they'll maybe move that data from that SQL server and from Oracle or from their Postgres into their data lake, their AWS data lake, their Google data lake, their Azure data lake, into that object storage as like in some, usually either as like has a Hive table or an iceberg table or a Delta Lake table, and then Dremio can read those tables actually very fast from the object storage.
I'm sorry to interrupt you. Is there like I didn't see an option for raising a hand, so that's why I keep interrupting.
Oh, okay. Let me see if that's something I can turn on. Why is it?
I didn't see one. I mean, I think there is, but This is
Okay,
Zoom.
no worries. What I can do? What can do? Let me see
No,
if I can.
I just had a quick question.
It's
So,
actually under reactions. If you click on reactions, then you'll see a raise hand button.
okay, I see that now. Okay, okay, I got it. All right, thank you.
Perfect.
I
No
see
worries.
that.
But did you have a question?
Yeah, so I just curious, I really like the approach that you guys have taken in terms of reducing or the size of these or the
Mhm.
enormous size of these pipelines and to shrink it and all that. And you focusing on more on the modeling side of things. So why is that the modelers still get paid on the lower end?
That well, I mean, that is a little bit beyond sort of like the
I
scope
know,
of
I know.
answers I have
I'm
right
just
now.
curious.
But
I was just curious why is the case because that's a pretty creative work out there, right? So
oh no, agreed. And I mean, basically, if you can shift basically where, because oftentimes a lot of the mind share goes into figuring out the data management issues. So then that's where a lot of times people feel like, hey, if I can just manage the data better, oftentimes sometimes people will think, okay, that will solve the whole problem, and now I don't have to worry about as much about the modeling. And that's where a lot of the mind share has been the several years. And the goal, of hopefully, what Dremio would like to accomplish to make that where that is less the concern, so that way that other thing can be more where the optimization is going, so that way you have an optimized model with optimized performance. But
right.
far as like the far as what companies choose to pay and what people are willing to work for, um, that that's going to be more market forces than anything.
All right. Thank you.
No problem. Cool. And basically, what happens is that again, we're going to connect our data sources directly to Dremio. So that could be your data lake. We can connect the data warehouses like Snowflake and Synapse and Redshift. So you can connect directly all your data sources directly to Dremio. So that way you don't have to move the data anywhere in particular. You use the data where it's already at. And that allows for a lot of different use cases, which we'll get into a little bit later on. But bottom line is the goal here is to minimize that movement, work with the data where it's at, and then you can deliver that data to where your end users are at. So basically, Dremio has several different ways you can deliver the data, whether it's via REST API, via RUI, via JDBC, ODBC, or Apache Aeroflight. There's different ways to get the data to your analysts, your data scientists, etc., and integrations with all sorts of different BI tools. So that way you can take the data pretty much from anywhere and deliver it everywhere. Okay. And without having to think about writing a big, large web of pipelines, you just connect your data sources, model your data, and you would model your data via logical views. And we'll kind of show you an example of that coming up on how that's all accelerated. So you'd model it via logical views and just distribute it wherever it's needed. And all of that can be governed from one place, uh, organized from one place, documented from one place. So it gives you a central sort of access layer for a large web of data sources and a large web of data uses. So again, we have federated data, meaning we can connect to many different
So
types.
just a quick one again. So all these are connectors that you're talking about, right? That you have in place.
Correct.
Mhm.
Correct. Okay. And again, just to keep the flow going, just make sure to use the raise hand.
Oh, okay. Sorry. Yeah.
Okay, no problem. Okay. So we have federated data sources. So we have connectors for all sorts of different data sources. Again, databases, data warehouses, and data lakes. And that's where the zero to low ETL terminology comes in, because you could go zero ETL where you just connect directly to your databases. That's possible. Again, depends on the use case and depends on sort of what your goals are. But you could also, what a lot of people do is they'll do a more low ETL approach where basically they're just really doing an export load. They would just take their data, load it into, like, let's say an Apache Iceberg table on their data lake, and then do everything else through logical views from there, as far as modeling their warehouses on Dremio semantic layer. And because Dremio has this nice semantic layer, which gives you this really nice UI where you can kind of organize all your logical views and create logical views very easily, you can create those layers of transformations logically and then give your users access to only the views you want them to have access to. So you don't have to give them access to the raw data. You can curate layers of views. So I could say, hey, I have, first I'm going to join these two data sets. That's a view. Then maybe I'll do some other sort of modifications for a particular use case and create views from that join. And then just give that particular user access to that specific view. and I can actually control the level of access they have to it. Like, can they only read? Can they read and write? Can they actually create another view from that? You have that kind of granularity of control over how users can access all these virtual data marts you've created. So instead of having to create like a bunch of physical data marts in a data warehouse, because normally you would move the data to a data warehouse, then you would create a bunch of data marts in the data warehouse and create layers of copies of the data. Here, you're creating only layers of logical views, so there are no copies. So you didn't copy the data in, and you're not copying the data throughout. So far, there's been theoretically no data movement, unless other than that, maybe that initial landing into the data lake in a data format like Apache Iceberg or something. And then, but now generally where this works, because like Dremio is not the first platform to say, hey, let's virtualize your data. Okay, there's been other platforms that say, hey, let's have a bunch of connectors connect your data and just work with the data where it is. Where the issue's been in the past is scale, because what happens is that, you know, if every time you're querying it, when you query a logical view, it's going to go back and hit that original data source. So eventually you're going to hit sort of scaling issues at a large scales. Dremio solves that issue through a feature we have called reflections. And we'll do a few examples of reflections so you can kind of see how this works. But what reflection does, it is essentially under the hood, taking the pipeline you probably would have built and taking all the guesswork out of it. Because what would have happened? If you were trying to accelerate a query on a particular view, you might have done what's called a materialized view. And now you've created this physical copy that you have to then go back and update and figure out what those updates should look like, create those pipelines, deploy those pipelines, test those pipelines, and then the things that would create another namespace that your users would have to be aware of. So there's all these little complications with that. But with Dremio, you can just turn on reflections, and Dremio is going to hide all that behind the scenes. Users are just going to notice that when they query that view, it's going to be faster. So Dremio enables the scale of that virtualization approach that makes life easier, because it's much easier for your end users to just think, okay, hey, I'm going to go query this table directly from the source, or I'm going to query these views and not have to think about all these different names for the same data set, depending on their use case. They just query the fundamental data set. Sandeep?
Yeah, so I'm trying to understand a little bit the architecture, right? So what you're saying is you basically doing federation and you going against, you're not physically copying data into storage anywhere, right?
On its surface, yes. So basically, when you connect a data source to Dremio, Dremio is going to inherently basically, depending on the source, like if it's a data lake, it's just going to query that data lake using Dremio's query engine. If it's like Postgres, it's going to push down probably the initial query, or any part of the query that can be pushed down will be pushed down to Postgres, and then do the remaining of the processing on Dremio's end. And same thing if it's
Well,
like
you bring the data all together and then you
correct. It becomes like
on
a funnel.
on the Dremio server, and then you run the query on that.
Exactly. So it'll grab
On
the
the
data from
all the copies of the data, right?
correct, but there's no like it won't create like another file. So there's nothing physically
Yeah,
being
it's not storing it; it's staying it in the memory, right? Basically.
exactly right. Exactly right. So and that's where like a something like an Apache Arrow comes in. But the benefits of doing this again is now things become simpler. There's less pipelines, which means less backfilling. So you're going to get fresher data sooner because your data doesn't have to go through as many physical movements. There's not as many of those writes that cost money, but also take time. There is a time component to physically writing files to disk. Okay, data consumers are getting fresher data faster. And again, you're going to see there's some little ways you can optimize this to get that data really fresh, really fast. Okay. Sandeep, I'm going to have you hold on for just a couple slides, just because in a couple slides, I'm going to kind of go over the overall architecture. So that might clear up a lot of upcoming questions.
Okay.
Thank you. Cool. And data consumers. Okay, getting fresh data fast. And then there's also the cost benefits. Because again, if you have less copies of the data, there's less storage costs. There's less pipelines. There's less compute. Okay, so those costs are going down. If you're not moving the data as much, if you're not moving the data into an external data warehouse, a lot of those egress costs are going to be mostly eliminated. Less pipelines, the more quicker the data is going to be refreshed and updated because you're not making as many physical copies. Okay, less copies, and all the data kind of can be sort of organized in one place. It's much easier to comply with regulations. You're going to have a much better sort of 360 view of your data because it's all visible in one place. Even it may be physically located in many places, but it's all visible in one place, which makes the mind share, the thinking through these things a lot easier. less copies, less chances that data models change because you're not transforming it as you're not creating these physical copies where you can have these data model changes happen as frequently. And again, better insights because you're working with fresher data. Okay. Now, how does Dremio make this all possible at scale? Okay. Like, so we get it. Okay. So I can connect all my data and model it. And my users are going to have it and it's supposedly fast. Yes. But how? Okay. So Dremio's sort of goal here is like high performance virtualization. You can bring in your data from many sources, but you can do it at scale. Okay. And how does it do that? It does it in several different ways. One, the query engine itself is very, very fast. Okay. It leverages something called Apache Arrow. Apache Arrow is an in-memory columnar format that's now become much more the standard in the industry. So you're starting to see like a lot of new projects adopting Arrow as the way they represent data in memory because it's really, really fast. But in the earliest days of Apache Arrow started out as the in-memory format for Dremio, and then kind of evolved into the Apache Arrow of today. So Dremio has been building and optimizing, working with Dremio Arrow structures pretty much for its entire existence. Okay, so it works really well with Apache Arrow constructs. Okay, allowing it to really process data in memory really fast. Okay, people are sometimes shocked when they see how fast they can query data, especially data on their object storage using Dremio. Okay, and how consistent that speed can be on their clusters. Because it's not just, hey, sometimes it runs fast, sometimes it doesn't. It can be consistently fast and consistently optimizing itself so it gets faster. Basically, there's also parts of Arrow that Dremio has contributed, like Gandiva. So Gandiva is this part of the Apache Arrow project that will pre-compile certain SQL subroutines to binary to kind of bypass the whole processing of like Java bytecode intermediaries. So it speeds things up. And then again, there's another part of the Aeroflight project called Aeroflight. And Aeroflight's how you send the data from, let's say, like, a Dremio server to your laptop. And when you use Aeroflight instead of like JDBC, ODBC, what happens is that the data never basically stays in the Arrow format in transit. So there's no serialization. There's no having to convert between different formats. So it's able to move faster because you're skipping the step of conversion. It's an Apache Arrow format when it's on Dremio servers and it's processed. Then it gets sent over the wire in Apache Arrow format. And then you continue processing that data in Apache Arrow format from your ad hoc scripts in your notebook or in your BI tool, etc. So avoiding that serialization again. So you process the data quickly and you can move the data quickly. And that makes that whole process faster. And there's a video on YouTube. If you look at like JDBC versus Aeroflight or ODBC versus Aeroflight, there's a video where I do this Python script, one that grabs the same exact data from Dremio using ODBC, and then the same exact data using Aeroflight. So you can actually see just the amount of time sometimes that conversion that JDBC ODBC does can cost in moving data from point A to point B. Okay, so like the query itself was completed very, very quickly at the same time, both situations, but the difference was the way it was transferred between systems. Apache Calcite is another open source project that enables like parsing of SQL queries. But not only does it allow you to parse SQL queries, it allows you to run cost-based optimizations, create custom rules for cost-based optimizations. And that's how Dremio is really able to optimize queries. You could write bad SQL, like you could write really not the best SQL in the world, and Dremio under the hood, it will sort of rewrite it and optimize that SQL under the hood, giving you a faster query. Okay, so now everyone has to be like a top-notch SQL expert, writing the most efficient SQL in the world, because Dremio using Apache Calcite can swap out and look for those sort of inefficient patterns and swap them out for more efficient patterns. So allowing everybody to kind of benefit from the best SQL paths to a particular question, regardless of sort of their level of SQL knowledge and SQL patterns. Okay, and then we have the reflection story. So again, so that first layer is just that Dremio's engine's fast, and again, the engine's fast because it uses Arrow for processing, and it can optimize your SQL using Apache Calcite. Now then, there's a reflection story. So the old way, okay, the way things are generally done now is, again, you move data from your data sources to your data lake, so ETL, then data lake to data warehouse, ETL. Then you're going to curate a bunch of data marts, so little mini data warehouses in that data warehouse. And then you're curating a whole bunch of copies of the same data in different forms under that. So you're modeling it all physically, not virtually. Some of it may be virtual, but most of it will oftentimes end up being physical. So copy after copy after copy. And you have to make sure that all those chains rerun every time to keep all those copies in sync. It costs a lot of money and can be the cause of a lot of stress. Okay, but with Dremio, basically we have a feature called reflection. So here's an example. Here I have a Postgres and a MySQL database that are connected to Dremio. So through Dremio, I can see a table that's on Postgres, and I can see a table that's in my MySQL server. I want to join these two tables. So I join the two tables through a logical view. Okay. And then from that view, I create two views for two different dashboards I want to create from that data. Okay. Or there's two different reports on that data. Okay. I can speed up all three of these by just turning on reflection. So even though this is still a logical view, behind the scenes, you just flip a switch on the Dremio UI, or you run an SQL query creating a reflection. And think of reflections are just, they are, so when you create a reflection, you are creating essentially a physical copy, but it's not just copying the data, it's creating an optimized copy. So it's going to create a Apache Iceberg version of the data that's optimized for, and you can actually set certain optimization parameters that's then stored on your data lake. So now next time I run a query on this view, instead of going back and running the query to Postgres and running a query to MySQL and then running that join again and then processing this view, what it'll do is that Dremio is going to be aware of the reflections that were created and where they are on your data lake, and it will swap that out. So basically, it'll have the pre-computed join on your data lake, and it will swap that out and any queries that basically in that lineage refers to that view. So that reflection would get swapped out for queries on this, for queries on this, and for queries on this. So instead of recomputing the join every time, is using the reflection, but I'm not creating a materialized view that the end user has to be aware of. Like they just keep querying the view. They don't need to know there's a reflection. They're just going to notice that the performance is better. And then all the views that are created from that view are just going to also just spontaneously be faster, because they don't realize it, but Dremio is intelligently knowing when to swap these things out. So instead of having to create one for every view, you can create one in this case for like that join, and that's going to accelerate multiple views because it's strategically done. And that, and then that kind of begs the question is like, well, how do I know when to turn it on? Like when is a good time to turn these things on? Because it sounds cool. It makes sense, have these things that I can swap out to speed up the right queries. But how do I know when to turn it on? Well, Dremio has added a feature in the last month that will recommend reflections. Okay, so basically what will happen is it'll monitor your query pattern. So it'll say, okay, hey, based on your query patterns, okay, you're accessing this view a lot. Okay, or you're accessing this table a lot. And it'll be like, you know what? Your queries would be faster if you create the following reflection. And it'll even give you the SQL to create it. So not only will you know which reflections to create, it will give you the SQL. So you literally just copy and paste SQL and create the reflection. And then your queries are now faster. So reflections have become easier to use and easier to identify when it's a smart time to use them. So instead of having to like kind of guess when you should create a materialized view or a BI extract, Dremio is going to guide you on doing it and even give you the SQL to create it and then manage and update those reflections behind the scenes. So you don't have to worry about that. Sandeep?
I'm just trying to find out if this reflection is some sort of like an AI model or something.
It's essentially
some LLM kind of a thing, or I don't know.
It's not an LLM. It's more just it's because it's not using like, let's say, AI to know what it's using. It's the actual Dremio is tracking the relationship between all of these views. So essentially, like what happens is that when it looks at this view and you query this view, it knows the SQL that created that view. So it's aware that that SQL refers to this view. And Dremio is also aware that a reflection was created on that view. So based on those two facts, it can then assess, hey, does the reflection I created on this view, will it be helpful for the particular query going on this view? So that's not done through necessarily AI, but it's done through very intelligent logic that allows Dremio's engine to make these intelligent decisions when querying your data. So that way,
so what reflection is what exactly? A piece of code? What is it?
It's just basically an Apache Iceberg table. So essentially, if I just turned on a raw reflection on this join right here, It would
Uh-huh.
just take that. It would just take the result of the join and create an Apache iceberg table
Oh,
on my data lake.
a physical table. Okay.
So yeah, so it is creating a physical representation in Apache Iceberg. And then what it does is that when it notices that I'm querying that or any of the views derived from it, it'll swap that out as the physical data source.
Also, it does a bootstrap, basically.
Correct. Yeah, it just kind of does a swap. So basically, on my query, it might look like, to me as the end user, I might think that my source is the Postgres table, but Dremio knows, hey, this is going to be faster, so it swaps it out and gives you, and then it will automatically update that as the, so it'll on a regular cadence check Postgres, check SQL to update that data set. So you don't have to worry about the updating of it. You don't have to worry about when is it swapped out. Dremio will handle all that for your users once it exists.
Got it. Got it. Pretty awesome.
Yeah, no, it's really cool. And then one extra cool thing we've done with reflections in the last month. So again, to recap, you have reflections, you can turn them on. It creates these structures that get swapped out. But now you get the recommendations. And on top of it, if your original source, so remember, I mentioned a lot of people, what they'll do is they'll land the data as Apache Iceberg tables in their data lake first, and then connect their data lake to Dremio. If the underlying source is an Apache Iceberg table, then the updates to the reflections are incremental. So if I have a reflections throughout my entire model, based on this Apache Iceberg table, when that table updates, almost all those reflections will update almost real time, because it'll be an incremental. It'll just be changing the delta using CDC under the hood with Iceberg to update those reflections. So basically, you'll get like the maximum freshness real-time updates to those materializations under the hood, which is really cool. But reflections don't just work for materializing. Like in that case, I was saying, hey, it created a copy of the results of the join. That's referred to as a raw reflection. So you're creating the results, you're materializing the results of a query, and then Dremio manages the materialization under the hood and swaps it out, does all the work. So you don't have to create those pipelines. But what about BI dashboards? So oftentimes when we have BI dashboards, we are basically creating charts based on aggregation. So like the sums, the maxes, the mins, the averages. And basically oftentimes running an aggregation on a large data set on the fly can get really not fast. So then what happens is your BI dashboards tend to be kind of slow. You might change a knob on your BI dashboard and have to wait like 30 seconds for it to update. Okay, not necessarily the greatest user experience. So the solution traditionally to that has been creating BI extracts and cubes. So what would happen is that you would pre-compute all these metrics. So you would pre-compute the sums, the averages, the mins, the max, and you would create these static structures, BI extracts and cubes. The problem with them is that you would have to create them, and then you would have to create them again. So anytime the data updated or on whatever your cadence is, you'd have to go back and recreate it. And essentially you're creating another thing. You don't delete the old one sometimes. So oftentimes like you end up piling up all these old versions of your BI extracts and cubes, and your storage kind of starts ballooning after a while. Okay. On top of it, so then that means that's something you have to maintain. So you have to go do the maintenance work to go remove those old copies of BI extracts and cubes. You have to create sometimes the pipelines to actually create these pre-computed metrics. And for very large data sets, these pre-computed metrics could be so large, especially if you're calculating like various, permutations of it, that you end up with out of memory issues when your engine tries to actually run the dashboard because the data is so large. But Dremio, when you turn on, instead of using BI extracts and cubes, you just flip the reflection switch and you create what's called an aggregate reflection. It's like the raw reflection, but instead of making a copy of the query results, it's going to pre-compute all the aggregations on the fields that you want to prioritize. So you'll choose like the measures and basically choose like what are the measures that you want to optimize for. It'll pre-compute those metrics and create its own structure. Like you don't have to know what it creates. It's just, again, it's an Apache Iceberg table under the hood, but it's gonna get updated incrementally. It's again automatically maintained, so you don't have to worry about updating it. Dremio will check periodically to update these reflections. There's no pipelines that you have to create. It's just going to get updated, and Dremio does all the maintenance. So it'll delete, any old copies, if any old versions of it, or update it and manage the data, split it up in a way so that way it can manage out of memory issues. So you won't have out of memory issues when you run aggregations on very large data sets. So all the headaches that you would normally have, you just don't have. You just flip the switch, and Dremio will take those headaches away from you. So again, all you have to do is think about the modeling of your data warehouse, and then in the places where Dremio recommends, you flip the switch and things get faster. Okay, Dremio will basically is doing all the thinking through of, okay, where are the places where we do maybe need some sort of cache to speed things up, and it'll recommend those to you. Okay, now just to recap, so again, Dremio is a fast query engine because of its use of Apache Arrow for fast processing and Apache Calcite to more intelligently process those SQL queries coming in. It has reflections, which allows you to create basically automated materializations that can be swapped out for queries on multiple objects, and stores those on your data lake. Now, another layer of how Dremio achieves performance is something called the columnar cloud cache, C3. And what this does is that it's going to save you money and performance. How does it do that? Well, when you have Dremio deployed as a cluster, you're going to have a situation like this where you have a coordinator node, which is like the one that actually receives the SQL and then tells each of the worker nodes, okay, this is the work you need to do for this query. Each of those worker nodes are going to have a little mini cache in memory. So an in-memory cache located on that node. And what it's doing is it's monitoring, hey, we access this Parquet file all the time. Okay. Like I've accessed it like maybe let's say 20 times in the last hour. Instead of me going back to S3 or ADLS and getting that Parquet file over and over again, let me just cache it on the node. So that way next time I have it. Okay. And again, not having to go to your object storage to retrieve every single file will reduce those egress costs, because again, you're not moving data out of your cloud network for each of these queries. Okay. So you're going to reduce a lot of your network costs when it comes to just retrieving data from your object storage. And two, your queries are going to be faster because they're going to be able, because one place where you'll hit bottlenecks with object storage is if you're sending a lot of API calls, because again, sometimes these tables might be huge. So they might be made up of thousands or hundreds of thousands of Parquet files. So if you're sending that many API calls, you end up with a bottleneck of, hey, having to retrieve all these files from object storage. But through the columnar cloud cache, you're not requesting as many files, so your queries stay performant, despite any particular object storage solutions, limitations on requests and things like that. So it manages or if you have something on like a slower tier, it can still kind of give you fast performance because it's caching a lot of these things. So you have the cache that's on the worker nodes. You have your reflections, which is kind of a cache that's on your data lake. And then you have the fast engine that's just naturally fast. And a lot of times, just the engine is fast enough for most of your needs. These other features are there when you need them. Sandeep?
I'm sorry, I didn't read. I just wanted to ask what kind of a cache it is. A data cache, right? So yeah, I just read that here.
Yep. It's just caching regularly accessed files on the worker nodes themselves in their memory. So the idea is that generally, like the Dremio clusters are going to have very high performance non-volatile memory, and then that memory is going to be used so that basically it'll be really quick for accessing during processing on those worker nodes. So by caching it there, you get really nice performance in the processing queries when you're processing data that you frequently process.
It seems like you build a virtual MVP, right? It's kind of a virtual MVP.
Kind of, yeah. So it's pretty cool. Like, so when you add all these things together, you get really good performance and consistent performance. And all this is why, like, again, and then consistency is a big deal because you can design a query and optimize things and get like a one-off really fast query, but again, Dremio will not only give you fast, but it'll do it consistently throughout the usage of the cluster. Now, another fun issue is scaling, right? Because what happens is that and this is a feature that you see on a lot of these kind of cloud products where you can scale your engine. So you have so Dremio Cloud. Okay, because there's two models for Dremio. There's Dremio Cloud, which is the Dremio cloud managed version. So kind of where you just basically sign up for free with Dremio Cloud, connect your cloud, and then Dremio kind of handles the management of Dremio for you. So it makes it, you can literally get set up in like 5 minutes. Then there's Dremio software. So sometimes you have to be on-prem, or there's some sort of regulatory need that you can't use the Dremio cloud product. So people will use Kubernetes and deploy on their own infrastructure. So there's auto scaling on both, but it works a little bit differently. So on the Dremio cloud product, you generally have t-shirt size engines, similar to like Snowflake, where basically you have like a medium engine, small engine, extra small engine, extra large engine. And each of these are deploying a different cluster of computers. And depending on the size of the cluster, it can handle so many queries at the same time. So then what happens is that you run into this issue where if you have a lot of people querying, you might want to have multiple copies of these clusters deployed to handle the concurrency. So, but the problem with like some solutions is that you put on multiple clusters, you might not be getting that big flow of queries all the time. So then you're also still paying for that compute during the time those queries aren't coming in. Okay. But Dremio has auto scaling. So you can actually set rules saying, okay, hey, I want this engine. I want it to be a medium engine. And you're allowed to replicate it up to like, let's say 6 times. So you can make 6 copies of this engine. And then if any copy it's not receiving queries for like, let's say 5 minutes, then turn it off. So that way you're not building up those costs anymore. So that way you're only using the capacity you need. Okay, so you can control what your spend is by controlling the size of your engine and the rules by which these engines spin up and spin down. And on top of it, you can create routing rules. So for example, you might have queries that are high priority. Okay, so you might have a very large engine and you can actually specify, okay, these queries go to this engine. And you might have low priority queries that you don't necessarily want to spend top dollar on. So then you can create a smaller engine and route those specific queries by those specific users to that engine. So you have a lot of control on one, how to scale, but also making sure that you maximize the usage of the scaling that you have. Sandeep?
No, I just had a quick. Are you going to go through the admin console of the
Um,
Dremio as well?
no, I'm not going to go through the admin console in during this talk, but I can definitely. But at the end, I can talk to it a little bit.
Okay. All right.
Cool.
Cool. Thanks.
No problem. Okay, but in summary, Dremio eliminates the need for data ingestion. The idea is like, well, let me rephrase that. It's removing the need for many of these pipelines. You're not creating these large web of pipelines. It doesn't necessarily mean some of the optimizations that you need to do aren't happening. It's just that Dremio is abstracting them away, which makes the process easier. And again, the easier things are, and you can, because often historically what you're doing is you have a trade-off between easy and performance. You can make things really easy and just logically model everything, and that makes everything very self-service because it's easy to understand, but then it's not very fast a lot of the time. Or you can have a complex web of pipelines that create a bunch of physical copies of everything, materialized views for that, and BI extracts for this. It's really complicated, not very self-serve anymore, because now it's so fragile that you can't really change anything unless it goes to the data engineers. So then the data engineers get filled with a backlog of stuff. Okay, you have all the right pieces set up in just the right way to get the performance you need, but if anything goes wrong, it all breaks. Okay, so you end up having this constant trade-off and these headaches either way. Dremio is trying to give you the best of both worlds, where you can logically model your data mart, have a very self-service delivery of your data, but still be able to maintain that performance because you can abstract that layer of optimization away from, not make it easier for the data engineer to implement it because they're just flipping that switch, and really easy for the data analyst to take advantage because they don't have to think about whether it exists or not. They don't need to know that, hey, there's 3 versions of this table. This one's optimized for this one's optimized for that. They just query the table. And whatever is the right optimized reflection, Dremio will figure it out. Dremio will swap it out. Okay, making that whole story for the analyst to get the best performing query and the engineer to be able to deliver that much easier on both sides. Okay, and again, that's because of those reflections. You're eliminating BI extract, materialized views. A lot of these sort of constructs that would require a lot of manual maintenance and work are now out of the picture. Okay, Dremio semantic layer, where you can virtually model the data, and we'll show you a few slides of that and coming up. But that's going to allow you to organize the data. So now I can virtually organize my data into different folders. So think of your folders as like different data marts. So I might create like an accounting folder, a marketing folder, folder for each business line, and then under that a bunch of views representing the data I want available to that particular business line. Okay. Again, Dremio is a high performance query engine because, again, Apache Arrow, Apache Calcite, also because of its caching strategies using the columnar cloud cache, which caches on the nodes, and the data reflections, which create those iceberg representations on the data lake and swaps them out intelligently. So you get all, and then plus you got auto scaling, which is all going to help you reduce costs and control costs. because you have a very clear view of, okay, this is the infrastructure I'm spinning up. These are the rules at which my infrastructure is created. Okay. And just to add one thing to that whole auto scaling story is if you deploy through Kubernetes, the Kubernetes Helm charts, instead of having like a cluster based rule, you have node based auto scaling. So you can set rules for saying, okay, hey, when certain metrics are met, it spin up an extra node or spin down a node. So you still have auto scaling. It's executed a little bit differently, but the idea is that whether you deploy on prem or you deploy in the cloud, you have auto scaling options. And again, you have that unlimited concurrency either way. So again, less pipelines, less costs. It's easier. Okay, so again, once it's set up, you're just connecting the data. You're just curating the views, granting the access, and then the user just uses the data. And that makes things a lot easier. And then you just take a look out for those reflection recommendations and enable those recommended reflections as they get recommended. Okay, so just to give you another example of just sort of like this at work, this is an example sort of like, hey, this is ideal world, right? Like I have my physical data, I create a join, so there's my first view. Okay, and then maybe I create a couple views targeted towards particular business units based on that view of the data. And then my users start curating all these different versions of those data sets based on their individual needs, individual reports that they're trying to make. Okay, but again, the color coding here is purple. Always think physical data, so that's like a physical thing. And then these blue tables, those are virtual tables, so not a copy. They're just a logical view on the underlying source. Okay. And Sandeep, I'll take your question right after I finish this segment because it's like a 3-slide segment. Okay. Now, basically, then what happens though, if I go back for a second, if I query this view, absent any optimizations, what happens? To get this view, we have to go through the whole step. The query engine has to rejoin the table, then apply any changes that this view applied, and then apply this query, and then deliver the data to the end user, plus any other queries that they may have asked for. So again, this is much easier. This is much easier to look at, much more self-serve for the end user to look at and understand. But again, performance, you start hitting these performance bottlenecks. So the way you would solve them is through things like BI extracts. So you then create, like in this case, BI extract J based on this particular user view, because we wanted to create a BI dashboard on this particular view. And now I have this thing I have to maintain, I have to keep track of. Okay. And then now the user has to know that this thing exists. Like they have to know that there's a BI extract J, and they need to make sure that when they use whatever BI tool they're working with, that it does it based on BI extract J, not directly on user view I. Like they have to like think that through. It complicates things because the natural intuitive move from the analyst would just to be build a dashboard on user view I. Like that's the data set I'm working with. Okay. So it may, and then the thing is that this particular structure might be just sort of outside of things, so then I can't really share it easily because Dremio also makes it really easy to share data. So it just gets complicated. And then again, if I want to now speed this particular like view up, I might go create a materialized view. So I'm creating all these things, and see now this doesn't look quite as pretty as that original just simple model where the clear usage or purpose of each data set was very clear, and there was only one version of the data sets that I needed. Okay. So where Dremio comes in, it simplifies it. We go back to where we started, where it's just logical views, and we just enable reflections. And again, behind the scenes, when Dremio sees that query coming in for user view I, even it'll know, oh, I should probably swap out reflection J for that. Okay, behind the scene, it knows what reflection it has, and it will swap them out. It'll alter that query. It'll optimize that query to query the optimized physical representation. And the end user, they could create their dashboard on user view I. They can run queries against user view I, and they're just going to notice that they're all fast and they're not going to know why. They're just going to be like, well, I guess Dremio's just like amazingly super unimaginably fast. And then Dremio's super fast, but it's the reflections that also really get you to those like mind-blowing performances and ease of use. Okay, when people see like how fast they can create a dashboard directly on their object storage in particular, and how easy that is to work with, and how effective it is, it's oftentimes a very sort of one of those light bulb moments when they actually try it out and get hands-on with it. So bottom line is we make the data very easy and accessible and self-serve for the analysts, So the analysts, they just see the data sets that they're going to naturally want to work with. They'll see it documented. They'll only see it if they have access to it. So any user starts off with zero access. So basically, you have to grant access to users to data sets based on their user or their role. So it's secure in the sense that like no one's just going to have access to the fundamental data source or a particular data unless you gave them access to it as the admin. Okay, and engineers, they manage the sources and they turn on the reflections when they're needed, and basically analysts get the benefit from all that. So it just makes this whole process much easier. But before I go that, I want to answer Sandeep's question.
Actually, you'll have to go back a couple of slides. I just had specific questions around. Yeah. So here, if I understand this correctly, the tables are basically the federated sources, data sources, right?
Exactly right.
Okay.
So this would be a table.
Yep. Yeah, and the join is a federation of that into some data store in memory.
Yeah, this will just be a logical view. So essentially, whenever I query it, it'll just redo the join, and then
yeah, it's going to be
memory.
It's going to be a cached data store, right, in memory. Is that correct?
Won't necessarily be like if it's a logical view, it'll run the query every time I access this.
Oh, it's going to actually rerun the query. It's not.
Yeah. So it's basically it's a view, not a materialized view.
Oh, got it.
But so if I want it to be materialized, that's when I turn on reflection.
It's going to go and basically run this, get the data in at that particular moment, and then run that the view again, right?
Exactly right. So exactly right. And then that's where the reflection.
And it's going to then cache this data, and then the business unit view is basically your like a filter into the join.
Correct. So it's like it's an additional query running some sort of particular filters, maybe some query, some column changes,
or could be an aggregation or a filter or whatever.
It's just some sort of a further enhancement of this data over here, and then over here even further.
And then the user view is basically like a actual set of columns that they want to see.
Yeah. So I mean, one example could be like, okay, hey, like this is my sales data, which I joined these two tables to create like a view of my sales data, and then this is like a view of that sales data for the marketing department,
right?
That has a couple of derived columns that particular department needed.
Mm-hmm.
And then basically this user over here is creating a report based on like March sales. So they created a view just on March sales that they're going to create the report off of.
Got it.
And whatnot. Yeah. So that essentially all it is it's just seeing that relationship between all the views. But again, right now they're just views. So every time you use them,
it's basically dynamic in nature, right? The whole thing is very dynamic in nature.
Exactly. And but because we can enable reflections, we get rid of that need to always go back to that source data and run that whole chain of queries again.
Yeah, because you're always snapshotting periodically.
Correct, because we have that sort of cached materialization, the reflection that we can swap out.
So do you guys also have when you do this unit E view, this what I'm understanding, you're building some kind of a query here, right?
Well, these are all essentially representative of a query. So this view represents a query, and then this is a query that's querying the results of that query, and this is essentially a query that's querying the results of this query. Mm-hmm. So they're like cumulative queries, but instead of running every query at every layer, the reflection materializes everything up to that point, but then swaps it out anytime, basically from there down. So basically, this reflection would be used to improve the performance of queries on this, and this.
Right. So reflection is basically a snapshot of the data, right? So that's...
Yeah. I mean, there's some extra bells and whistles to it, but yes, it's using Apache Iceberg, which gives it some certain performance optimizations, and you're actually able to configure how it's sorted and partitioned. So you can actually have multiple reflections on the same view that are partitioned and sorted differently, and they'll be swapped out.
So you have some storage optimization done there.
Yeah, so you have some really easy knobs to kind of set that, and then so I theoretically, like an example I like to use is like voter data. I could have I could create two reflections on that same voter data and say, okay, this one's partitioned by state and this one's partitioned by political party, because I expect queries that might benefit from both types of both types of structures. But again, thinking all that through is much easier because
Like
Dremio is going to figure
creating
it
like
out.
micro partitions.
Well, they're just going to create two separate, essentially two separate materializations with different partitioning rules, and then
Okay.
keep them synced.
Oh, got it, got it, got it. Okay.
But nowadays, again, how many of these do you need to make? Because one of the problems that used to happen in the past is, again, thinking through when do I use this. Now with reflection recommendations, you just wait for Dremio to tell you when, and it'll give you the specific SQL to do it. So basically, monitoring when you should be doing these things becomes much easier because Dremio will notice those sort of hot queries, those queries that should be running faster, and tell you, hey, you should probably run this reflection query and create that. So that way you're not creating too many reflections. Because a lot of times Dremio is going to be fast enough that it can handle most of the queries naturally without the need for reflection. So, but it can help you identify when you do need one, so that way you don't create too many and end up with because you are taking some storage when you create one, so you don't want to create too many of them. So Dremio will help you through all that. So the idea is that Dremio is doing all this work and constantly self-analyzing itself to help you manage this lakehouse much more easily. Cool. And then that brings, okay, so now we're gonna just kind of walk through the steps. So imagine that you were right after this to spin up an instance of Dremio. And if you wanted to do that, the easiest way to do it would be just open up a cloud account. You can just quickly open up a cloud account in a few moments, connect it to your cloud, and have a Dremio Lakehouse that's ready to go. Another way, if you just kind of want to test it on a smaller scale up front, I do have a blog that'll walk you through just spinning up Dremio on your laptop with like a Docker container. And then you can kind of go through the whole experience of connecting like an object storage that's also running on your laptop and just kind of seeing how it all works all on your laptop. So there's zero infrastructure costs, zero having to connect the cloud account. You can just see that work on your laptop. So there is a blog. I'll link to it at the end. But we're kind of talking about
It's
that.
pretty straightforward to set up.
Yeah, the
Like locally on the machine is pretty
yeah,
straightforward.
the local setup's completely free, no cost.
No, I mean,
No.
is it pretty straightforward to set up?
Oh yeah, super straightforward. Like I literally give you the exact like Docker compose code to do it. So literally you just copy the Docker compose file that I'll give you in there, type in a command, and it's up.
All right, cool.
Yeah, it's super awesome. Like it's really made it, and it's like people are like enjoying it because like it's also become a tutorial that people are using just to kind of like practice data like working with object storage on their computer, because you have like a little Minio cluster that you'll have on your computer that you can work with. It's pretty cool. But again, let's assume that you create that Dremio cluster today, whether it's you'd self-deploy with Kubernetes, or you spin up a Docker container on your laptop, or you go to Dremio cloud and sign up. Okay, first thing you do, first step is connect your data sources. Okay, so I might go connect my operational databases. I could connect them directly to Dremio, or I might choose like the more low ETL approach, where I'll ETL that data into iceberg tables in my data lake. Okay, either way is fine. But again, these are just showing you like the different options. I can actually upload files on Dremio. So you could actually give your ability, like if you have a lot of users who are using Excel and working with Excel spreadsheets, they can literally just upload their Excel spreadsheets and now query them like tables. Okay, and work with them and then join them with other data sets without having to do any work to convert it into a table. It'll just now work with everything else. Same thing with CSV files, JSON files. They can just upload files that they're ad hoc. You can connect database. You can, another use case is maybe you've been using Delta sharing to get some Delta Lake tables from a third party. Maybe you've been using Snowflake Marketplace to go get data from a third party via the Snowflake Marketplace. All of this data can then be unified in Dremio instead of having to like keep moving around different copies to different places. Sandeep?
Does it integrate well with the Databricks?
It can read Delta Lake tables, so it doesn't necessarily need to work with the Databricks platform per se.
Also, you can go to ADLS directly and get it.
Correct. Basically, because really, what the Databricks platform is going to do is you're going to just be using Spark or Photon platform and reading and writing Delta Lake tables.
Right.
Dremio just needs to be able to see those.
It just needs to have access to the ADLS.
Yeah, exactly.
To the Parquet files, right? That's pretty much it.
Exactly. Yeah, and the metadata, which will all be co-located.
Yeah.
So
right.
you just give it access to your storage, and it can see those Delta Lake and Apache Iceberg tables on your object storage. Yep. Cool. But basically, you can connect your data sources. So wherever your data is, you get access to it. Okay. And then where you can access that data is constantly growing. There's some pretty exciting connectors that are going to be released in 2024 that I don't want to quite spoil quite yet, but it's going to be pretty exciting. And open up some really cool new use cases. But again, once I connect my data sources, then I would go create those virtual data marts. So I can go create a folder for each. So in the same way you create a data mart, I would create a folder for each business unit. Okay. And then in there, I could maybe practice like a medallion architecture. So I can organize that data, land a view of the raw data in a bronze folder in there, and then maybe curate some of that data into a silver layer there, and then into like that gold production layer there. And then maybe where I end up creating my reflections is here on the silver layer. So that way the silver and gold data sets are faster without having to create that whole chain of copies along the way. Okay, so this is like just kind of an example of kind of like how that modeling may look like, where again, I'm just kind of traveling around. And then what I do is I'll just grant permissions to the right users. In this case, I probably would do it through like, I would create 3 roles. I would create a marketing role, a finance role, a sales role, and then assign users to those roles, and then assign those roles access to the proper folders. So I might say, hey, all the finance people have access to the gold folder, and then anything in like silver and bronze, I'd have to specifically grant access to, or however, depending on sort of what you want to do. But you basically, again, everyone starts off with 0 access, and then based on the roles you grant them, or you giving them a grant to that user, you grant them access to individual objects, so individual data sets, folders. So that's how you would grant access. So you kind of work from bottom up. So usually you would try to don't give access to any, like in any platform, you always try to start off with like the minimal permissions, and you build up from there. Okay. And again, the reflection recommender will help you know when to create these reflections. So I wouldn't just rush to create reflections because it seems like a good idea. You wait till like Dremio recommends it. You'll know when, or if you kind of hit a situation where there is a dashboard that really kind of could use the extra speed, then turn on ag reflections. But most of the time, Dremio's reflection recommender should have your back and tell you exactly when you really need to run these. Sandeep?
Sorry, I'm asking too many questions. I really apologize for that. I just wanted to understand what is there any interaction between the reflections?
Yes. Well, let me think about that. Yes, because like one example could be like, let's say I have a reflection on 2 tables, and then I join those tables. It'll be essentially joining the reflections. So there's different ways that the reflections will interact. And sometimes it'll actually, I think sometimes it'll actually even use partial reflections to achieve to fulfill certain queries. Like it's pretty smart on how it does all that. So like this.
But as a developer, I don't have any control over the reflection, right?
Not anymore. That's another new feature that came out of the last couple months. So now there's a new feature called reflection hints. So for a particular query, if you want to make sure that, hey, this particular query should always hit this reflection, you can actually put a comment in the query, and you can actually specify that. Or you could say, hey, never use reflections for this query. You can actually put a comment saying turn off reflections, and it'll always just go to source.
So it's like an override, basically.
Exactly right. And where that's useful is that there's another feature, like this is like a little bit more advanced usage, but there's something called external reflections. So maybe there's a certain optimization that's not like obvious, or it's a really sort of like unique situation where you do want to create your own physical copy, like you want to create your own reflection that you manually maintain. You can do that. So you can create this custom iceberg table that you create external to Dremio, and then you can actually register it as a reflection with Dremio, so that way it becomes listed in the list of reflections that Dremio would consider to swap in a query. So not only will Dremio create reflections for you, Dremio will allow you to create your own and register them if there's a situation that makes sense for it. I wouldn't say how often that is a thing you need to do is super regular, but it's a thing you can do. Sandeep?
Sorry, another question. So when you do that, it's like auto registration, or you have to manually go and register it?
If it's an external reflection, you'd have to manually run a query that'll say, hey, I'm creating this external reflection that's supposed to be linked to this view, and it's located here on this object storage.
Or it's not through the admin console or anything?
Oh, it's through you would just do it through everything's done through SQL. So you could do the SQL through the
Oh,
admin console,
it's through SQL. Okay, okay.
or you could submit the SQL through like the REST API or something like that. So like there's people who literally will create whole applications on top of Dremio. So they'll connect all their data sources on Dremio and then create like customer facing applications. And then basically what's happening,
all the administration part is done through SQL.
it can be. So basically it allows them to create their application that can send REST API calls to Dremio to handle like the creation of a user account, the granting of control, the granting of like view on a data set. And so they can automate the whole thing and create whole applications on top of it that just allow users to get access.
You don't have a UI to do that, like.
Oh, we do. I'm just saying that like even when you use the UI, what's happening under the hood is SQL is being sent over to Dremio.
No, I understand that, but at least you don't have to hand code that, right? So.
Oh no. And then even the Dremio UI has a lot of tools to help you write the SQL.
Okay, so I mean, okay, got it. Yeah.
Cool. Okay, and the cool thing is that so basically, just to kind of recap, you've connected your data sets. You now want to create your virtual data marts, your logical views. Now you could again hand write the SQL and create every view manually, but now we have a DBT integration. So you could use DBT in the same way you would use DBT modeling anywhere else to orchestrate all of that. So that way you can just kind of create your models in DBT, and then it will orchestrate the creation of all the views. And it will just run the SQL that creates the view. And then basically I would update my data, or I'd update whenever my data sources update, I can rerun those DBT models and it'll re-update those views. And those views in Dremio are now versioned. Like in Dremio Cloud, the default catalog has versioning enabled. So every time those like views change, there's actually a commit, and you can actually go back and time travel the view. So if you wanted to, like, let's say you've changed the view a lot because the models have changed over months, and that particular view changed, you could actually run queries where you can time travel the view, not just the tables, but you can time travel the view and run a query on the view as it was maybe several versions ago. That is kind of a newer, it's like a little bit more on the cutting edge. So like how often you would use that nowadays depends on the particular use case, but there's a lot of cool new versioning capabilities that are now in Dremio that are opening up some new possibilities that we'll be exploring more this next year. So keep an eye out for that, because just on its face, it offers some really cool stuff in the sense that, like, hey, something goes really wrong, you can roll back your entire catalog to a previous point in time. Or if you wanted to tag a particular point, like tag your catalog at the end of the month, you could you could create a tag, so that way you can always replicate that particular state of your catalog at any time. So there's some cool possibilities that are now possible with this, what's called our Arctic catalog. And but again, early days and kind of figuring out what are the sort of how are these new cutting edge tools, these new cutting edge patterns going to look like. But pretty exciting stuff. Okay. But again, just to show you the example, like, because again, everything in Dremio can be done through SQL. So that means everything can be automated through Dremio's REST API, sending over SQL statements to the Dremio cluster. Okay, because people literally build like customer-facing portals on top of their Dremio clusters. It's really neat the way some people use Dremio. But again, granting people access is as simple as an SQL statement. So you can see here, it's pretty simple. Grant select on all data sets. So in this case, we're literally giving this person access to everything on a particular project, and then we're just giving it to user one. So these are just all examples of different like access granting queries. And again, you can do that through the dashboard. Like there's literally, you can right click and it opens up a little like UI where you can say which users access. So you also have a UI on the admin panel to do that. But again, you have the SQL option if you're doing it from, custom Python scripts or something like that. You can do column-based access controls. This is great when you're trying to protect like PII, private identifiable information for regulatory purposes. So you can create rules saying, hey, if it's someone from, if they are not a member of accounting, then they don't see the full social security number, or whatever the rules are. You can sit there and say, okay, who has access to that particular column, and if they're the wrong role or the wrong user, you can put a mask on the values in that column. And basically that allows it where basically you don't have to create multiple copies of the table, because the column access rules will make sure that only the right people are seeing the sensitive data and the wrong people aren't. Same thing with like, and the ways that works is you create a UDF, a user defined function, and you apply it to the table. So again, all done through SQL. Same thing with row-based rules. So you can, again, create a rule, and based on whatever logic you choose, it'll say, okay, hey, can the user see this row, this row, this row, and it'll run that logic on each row and only show the user the rows that they should have access to. Okay, so that could be like, for example, if you have like a table of sales and you only want a particular agent to be able to see their particular sales, you can construct a view where, hey, you can only see sales where like your username matches the name of the agent who made that sale. So that way, instead of having to create like a view for each individual user where they would see their sales, you could just have the table of sales and create the access rules so that way they only see their individual sales when they look at that table. So there's cool stuff you can do with that. Like so you have really granular access control. Okay, so it's a very, very secure system. Then again, just Dremio has passed all these like security certifications. It's a very secure platform. But again, now, so basically, just to recap, I connected my data sources. I logically modeled my data, so created that layers of views. I granted access to those views, and now my users use the data. So in this case, my user might decide to create a BI dashboard on a data set. And most BI tools should have a Dremio integration. Okay, Tableau and Power BI have it literally built into the UI. So there's actually a button you can click to connect a particular data set to Tableau directly from the Dremio UI. Same thing for Power BI. Okay, and then usually connecting most other BI tools is pretty easy because again, they're going to generally have some sort of Dremio integration that's pretty easy to use. But again, if it's not running fast enough, we just turn on reflections, and now that BI dashboard is faster. So we don't have to go connect that BI dashboard to a different data set. We don't have to do anything. We just flip a switch, and in whatever time it takes to create that reflection going forward, that those BI queries are going to be a lot faster, and you can now move on to the next thing in the backlog of things that need to be done. So it just makes a lot of those things really easier. Like that's probably like this is probably a use case that I see. Like a lot of people will use Dremio just for this. Like they will set up a Dremio cluster, and this is like the reason why, because this makes such a difference in the performance of a lot of people's BI dashboards. It makes it so much easier to kind of maintain those dashboards' performance and be able to actually generate more and more dashboards because users can self-serve, create their views, and have performant dashboards on the other end. So like that is very compelling for a lot of people. But again, all of this stuff you can connect to Dremio via, as I mentioned before, you can connect it through REST API. Okay. You can connect through Apache Aeroflight, that very fast transportation layer, which is, here's an example of me connecting the Dremio with Apache Aeroflight and pulling in some data. Or I could use JDBC ODBC. So here's an example of me pulling in some data from a Dremio cluster using JDBC ODBC and putting it into a Pandas data frame. Actually, at the end of both of these, I'm putting it into a Pandas data frame. And then I can do my analytics from there. Okay, in my Jupyter notebooks. You can build applications on top of it. Like in this example code here, I built a Python server using Fast API that allows me, and then I have the front end UI here made through Jinja. Okay, and basically what this does is that I can type in an SQL, like not the most secure application. It was a quick, so I can have enough, the code can fit on a page. But you can type in the SQL query in a form, and then it'll actually send that SQL query to Dremio, let you download the data, and it'll make a chart of that data. Okay, so like a little mini visualization application. Again, I wouldn't. You always want to make sure you sanitize your inputs, to avoid SQL injection. But again, just an example. And but that's like the whole Dremio story. Like it makes it easy to take your data from everywhere, organize it, not organize it easily in a nice clear way. That's a semantic layer. Be able to grant access in a granular way, and then deliver that data to any kind of use case you can think of. Okay, so it makes where all your data, brings it all together and makes it available to wherever it's needed, and does it in a way that's easy to do. Literally sign up, connect my data sources, create my views, grant access, let users do their thing. And then that's the whole story. So that's what Dremio is, and what basically enables that whole idea of zero ETL. Because again, when you think about that whole process, nowhere in that process that I have to move data whether I was moving data into a warehouse or moving it throughout a warehouse through data marts. Okay, so that's the whole zero ETL virtual data mart story. When you create a data lake house using Dremio. Again, my name is Alex Merced. You can follow me on Twitter at AM Data Lakehouse or subscribe to any of these podcasts. They should all have new episodes next week. I didn't have really any episodes this week or last week because I was traveling a lot. But I'd like to talk about all sorts of random data topics. I like to talk. Again, I am a co-author on this Apache Iceberg, the Definitive Guide. It's a book that's coming out next year all about Apache Iceberg tables. You can get yourself an early release copy by scanning that QR code right there. Okay. And I would love feedback on the talk. So if you guys enjoyed the talk, and I would love to hear your thoughts, just scan the QR code and it'll take you to a form where you can kind of just give me some feedback, like what you thought of the talk and what you liked, what you didn't like. I'm always looking to, improve my communication, improve what I'm doing. So I would love to hear your feedback. And if anyone's watching this on YouTube after the fact, please fill out that feedback form. I'd still appreciate it. If you even if you watch this recorded, I want that feedback. And Sandeep, go for it.
I'm sorry, man. I didn't mean to.
No
It's a great session, man. Thank you so much
Thank you.
for that invite. It was an awesome. I learned a lot. But I'm just curious, and I think I am forced to ask this question. Isn't this product kind of a little? I'm not getting the right word, but for the data engineers, it's going to reduce the number of jobs for them, like for data.
No, because basically what we see at a lot of firms is that they can't find enough data engineers because the backlog of data work that needs to be done is just long. Because
right. I mean the fact that I do data engineering work, and it is pretty, as you said, it's invasive and it's time consuming, and it it's painstaking. But you guys are actually making the whole thing easier. So obviously, my workload, I mean, I won't have to struggle that much to do the ETL part, right?
For certain parts, like there's still going to be there's still going to still be probably certain pipelines you have to build for certain specific use cases, but you're not going to be building as many of them. Also, basically, you might be building out access to new data sources, because oftentimes what happens is that you not only are you short on data engineers, but the backlog is so bad that your data engineers are just focusing on maintenance instead of focusing on building out new projects. So what's happened at a lot of firms is that basically that savings of productivity has just made it where those data engineers can now work on new projects, and now the number of data, the number of data products they're able, or data, and then the reach of that data platform now grows faster. And then also because it's easier to use on the other end, you have a lot more people in the company using the data. So because there's a lot more data people throughout the company self-serving the data, there's also other needs that come out of that. So oftentimes it expands the usage of the data platform, which is what everybody wants. But usually you're still going to need your headcount that you have after that. And where people usually what happens is that I wouldn't say no one ever saves money and then just says, okay, we saved money. Usually what happens is that they'll save some money on the cloud costs, and then that immediately gets reinvested in some new data project that they've had in the back burn for a while. So then those
I'm seeing some. I've been in the industry for a very long time, so I'm seeing some very like a back to square kind of a thing going on, like where a lot of people are moving from cloud back to on-prem now.
And that's a really good point. Okay, so Dremio is really good for that in that use case, because Dremio is one of the few tools that works on-prem and in cloud. So for companies that are moving their data anywhere, Dremio becomes a really good tool for that. Because one of the big frictions when you're migrating is that usually the tools you're using in the cloud are different than the tools you're using on-prem. So then you basically, what happens once you do the movement, you have to retrain everybody on the new tools. But using Dremio as your sort of interface, Dremio can connect to prem and cloud. So then your users are only using one tool, and then as the data moves, they don't even notice because they've just been using the same tool to access the data. They don't really care where the data is. So a lot of companies use that when they actually usually we see it for like cloud migrations. So they'll connect Dremio to their Hadoop cluster. They'll immediately just see that people are getting better use out of their Hadoop cluster because it's faster. than a lot of other options on Hadoop on HDFS storage.
So,
And then, yep.
yeah, sorry, I'm sorry to interrupt, but I have to ask this question because I just had a listen to a OpenAI talk, so which was very, very interesting. So you guys, do you have any integration with any of the OpenAI products out there,
There
or
is some generative AI features. Now, how those generative AI features are implemented currently, I don't know the exact details, but we have two main features that are currently available in the Dremio Cloud product. That is one, SQL, text SQL. So you can like, what you can do is you can actually select, okay, these are the data sets that I'm working with, and then you can type a prompt and it'll generate the SQL for you. So I can say, hey, I want to join these two data sets and get this, and it'll write the SQL to do that job.
right? Cool.
Yeah, and
And
then the
you don't have to really build a custom like a custom
nope,
made for
it's
that.
already built in, and there's a couple other places like,
That's pretty cool. Yeah, that's
yeah.
nice.
The other place where it exists is that we have in the semantic layer, there's a wiki. So every folder and every view or table has a wiki associated. So you can provide documentation right there in the UI. So that when users are browsing the data sets that they have
Oh,
access to, they can actually read all about it, see like, hey, well, this is what their schema is. So now you can actually generate that documentation using generative AI. Like there's a button you can click, and what it'll do is it'll read the schema of the table and try to understand the context of the table and give you some basic boilerplate documentation, and then you can customize it from there. But that way you can at least have like good documentation of like every table schema that's like right built into the wiki, which is really cool.
and
And then
does it also have like those IDE features, like where you type in something and it's like, for example, you don't know the source of the table name or the context or whatever, right? You put
there
it in
is
and
this
like
on
a type ahead kind of a thing where it shows like a drop down kind of a thing, and then
yeah,
oh yeah,
there will be a search feature in
yeah.
Dremio Cloud in the future. It's not there currently. There is currently a search feature in the on-prem software version that will be replicated in the cloud version sometime in the future. It is being worked on. But you'll have ability to like, and then you have data lineage in the admin views for each table. So if you like, if I'm looking at a view and I want to know, hey, this view is based on this view, which is based on this view,
Hmm.
which is based on this data set, you have a
That's
lineage view as well in the dashboard.
Oh, you mean like some aspect of governance is also
Yeah,
in
yeah. It's you have a lot of different ways to observe the data. So you have a log of every transaction and all the details of the transactions. You have the lineage for every view. You have the wiki to provide documentation. So there's a lot of knobs that can help you if you're administering the cluster to have the information you need to understand what's going on the cluster.
I mean,
Um,
I'm assuming it's all RBAC, right? Role-based access.
you have RBAC, and then you also have the column-based access rules and the row-based access rules, but mainly is RBAC.
Oh, okay, got it. Oh, so you can go actually one level down to the column level too.
Correct. So there's column and row-based access.
Okay.
And then was one more point I wanted to say about that. So let me just retrace my footsteps for a quick second. Okay, so on-prem. Okay, and then yeah, let me just finish about the on-prem thing. People basically put Dremio on their on-prem, and then they'll connect their new cloud, and then basically, all that's happening is they just update their queries as they move data over. So once this table moves over here, they just change the queries that all the views are built on to now query the version of the table that's on the cloud versus the one that was on prem, and people don't even notice that everything changed. Like it'll just be like everything just kind of works, which makes a lot of those cloud migrations, and theoretically cloud to on prem, much easier. So bottom line, like Dremio is just a great way for any type of migration, whether it's cloud from prem to cloud, cloud to on prem, from cloud to cloud, because that's also a thing that can be used for. So it's pretty flexible. The idea is that it gives you just a unified access layer, so that way you abstract where the data exists to all your users, so they don't have to worry about that. Like, as it doesn't make the life of the engineer easier in the sense that if you're doing that migration, you still have to think through how am I going to migrate that data over, but at least your end users don't have to have any friction in using that data in the meantime.
It's pretty awesome. Pretty awesome.
Thank you. I agree. I definitely get pretty excited about it when I talk about it. Like it's a pretty neat technology. But with that, is there any other questions that anyone has? I'm more than glad to answer any questions or address anything. Again, thanks everybody for sticking around for this. This is the end of the presentation, minus any questions that you may have. Again, hopefully you guys enjoyed all this. This will be posted on probably on YouTube in the next 24 hours. Once I generate the video, but yeah, yeah. Thank you guys for sticking around for this presentation. It's very appreciated.
Thank you.
Alex, I just want to say thank you again. I loved the first time you gave us a talk, and I hope you can come back and give us another one. Um,
Aw.
I don't have a lot of questions about this other than what would it actually cost my little health uh they are a primary care provider network, and they're dealing with data that comes from health insurance companies, mostly as Excel data, and it's always annoying to them. Like I'm doing a data science project for them that's kind of unrelated in a way, but
Mm-hmm.
I hear what these guys are going through all the time, and my heart bleeds. And I wonder if you might be able to give us a talk sometime on data ingestion, um, difficulties and how to solve them, like specifically from Excel files and like they're always changing things. They're always dealing with this file came in differently this time and they have to deal with how to manage it. And that's like I'm not even doing that work, so I'm not sure I even totally understand what problems they run into, but it seems like that's their biggest problem most of the time.
Got it. So it's managing is like so they have like a flurry of Excel files that are coming from different places and they're not consistently written.
That's yeah, and they're always dealing with changes and and it seems like I'm not really sure what happens downstream of that, like how they have to, um, then run everything over again.
Mm-hmm.
I feel like some of what you're talking about might help a lot because of your deltas, and I'm not sure that they are taking advantage of any kind of technology at this point that uses that. Um, where I imagine if so let's see. Do you know Alteryx?
I'm familiar with the company. I wouldn't say I'm like intimately familiar with them. I am speaking I forget what the name of the specific I think they're the ones who do OSA Con, which I'm
They're
speaking at next week.
okay. So they're like a data pipeline company, and our our senior analyst is using that a lot. And so I was just like that might give you a context for the kind of thing they're dealing with. And so the Alteryx gives them a GUI to create flows, an icon
Mhm.
based thing, and then in each icon they can set up parameters to do transformations and that sort of thing, and then load it into a SQL server.
Got it. Okay, so they basically what they're doing is they're taking the Excel files and loading them into SQL Server.
Ultimately, yeah. And then they use Domo, but they're going to switch to um, Power BI
Mhm.
for their uh, main like business output
Got it.
for visualization.
Got it. Okay, so I mean, if they're I mean, well, I guess it depends on sort of like what the intention of like are they using the SQL Server as because that's what they want to be using, or was that just some sort of patch? Because Dremio usually basically takes care of the data of sort of once it sort of lands. So basically, you would connect it to the SQL server and work from there. But the pain is coming from the Excel to the SQL server. It sounds like.
That's the feeling I get.
Yeah.
Yeah.
So there, I mean, I guess it would. I mean, Dremio, you could upload the Excel files, and then you could theoretically not even have to move it to the SQL server. You would just model the changes you're making and the joins and all that stuff,
Huh.
which may or may not be a solution in this case. I probably would need to know a little bit more. But the cool thing about Dremio is that you could try it out for free. Like a Dremio cloud account is free. You would just connect it to, a cloud. You can connect it to either AWS or Azure right now, and they could try it out on a small scale, see if it makes sense, and if it doesn't, it doesn't. But at least they're not like signing a huge service contract before they did that evaluation. And then
Mhm.
they can always reach out to if you reach out to have a consult. We do complimentary consultation meetings where we can sit there and like discuss the use case and kind of see if it's a fit. Um, because if it's not a fit, it's not a fit, but we can at least, give you an idea of where the right direction is to solve the problem.
Cool. I'll let them know, and I'm glad this is being recorded because I'll suggest they watch it. And a lot of it honestly might mean more to them than me because they know their problems better than I do, put it that way. But I'm just
Yeah,
kind of like an observer of what they go through, and I just feel like something like this might be able to help.
yeah.
So,
I find that generally, probably in most data stories, there is probably at least one use case where Dremio is going to be useful. Again, and that's the great thing about Dremio; it's flexible, so it doesn't have to, like, the goal doesn't always have to be, hey, Dremio's here, we're going to replace everything you're doing. It could just be
mhm.
like, hey, we have this particular thing, this particular pain we have now. Dremio relieves the pain, and in the future, there's other places that makes sense. Then you incrementally adopt it. It's flexible in that nature. It doesn't force you to kind of have to do anything particularly differently or move your data because it can connect to wherever your data is. So it gives you that flexibility.
Absolutely. That's what I kind of imagine. I mean, that's the only way that anyone would really want to adopt something new like that when they already have a system that they're using that works, right?
A
You're not going
hundred
to
percent.
just, so it might be interesting to see if there are any use cases they have where this would help them. Um,
Agree.
so thanks again. I'm definitely filling out the form, and you'll see like a very long any other feedback that I gave you.
I love that. I
So
love feedback.
you'll know, yeah, it's not it's kind of very simply describes what I just said. And
Okay. Awesome.
anyway.
I will be sure to read that. It's going to be literally probably the first thing I do after this Teams call ends. One other thing I want to point out is that this is the blog I was talking about where you can try it out in your laptop. So, like, go here to
Hmm.
dremio.com/blog. It's just like a little bit down the page, but this
I
blog
have
right
it
here,
open already.
yeah,
Yeah,
it'll
thanks.
basically
Great.
walk you in like 20 minutes. You'll have well, actually even faster than that. You'll have been hands on with Dremio and seen it in action and have a good idea
So
of what it does.
okay, I will definitely try it out. The thing with things like this a lot of times is
Mhm.
that it's kind of magic, and with a few clicks of a button, all of a sudden there's this thing, and then it's not always obvious what to do with it or what it's doing. But I'll definitely work through it and see what I think.
Agreed. I try to kind of give the step by step and explain the what throughout the blog as best I can.
Yeah.
So hopefully that helps. But yeah, like it's a good encapsulated version. Of course, like, depending, well, if you're using Dremio Cloud, it's literally just sign up and the clusters are ready to go. If they go like the route of using, like, deploying to Kubernetes, it's there's a Helm chart that makes it pretty easy, but not as simple as just spinning up a Docker container, but it's still
Hmm.
pretty simple. But yeah, I mean, it'll give you an
So
idea of what the value proposition.
yeah, and one thing, like your last talk, you were, I mean, you guys, you deal with big data with a capital B. Like your system is designed to handle
Yes.
as big as it gets. And this is
Trust me.
kind of the other end of that spectrum. I'm not even sure you would call it big data, but it seems like it still might be useful in the time that people spend.
Agreed.
Is
I
that?
think I would say, like, a company of any size can benefit from Dremio, in my opinion. That's the reason why, like, we built Dremio Cloud, because that way the benefit of Dremio could be more accessible to more varieties of enterprises.
Hmm.
But Dremio is built for, like, big data scale, so it's a solution that can work at a very small scale, but can grow with you. It's not like, hey, you now get to a certain level and now you have to go move everything over to a different platform, because Dremio is built to sort of scale to what your use case is.
Yeah, I get that. Like from the first one and from this one, that you know, you don't have to worry about, oh, now the company's too big for this tool that we have, so we have to look for another one. Something like this would just continue to work. So that's very attractive also.
Agreed. Yeah, but yeah, you're right though. We do go up to big scale. I forget the exact number, but I want to say it's like 5 out of the Fortune 10 are Dremio customers. So they're moving very large amounts to the system, and it's working. So
That works, yeah.
it's
So
robust.
I actually just asked let's call it GPT how much it costs, and it said like expect like $100,000 a year or something, and I think for this company it would be minuscule. So I'm a little curious about how to calculate. I think it's a CDU or something, your consumption units,
Yeah,
if
so
we went enterprise.
that's if they need enterprise. So yeah, so generally you probably if it's if it's that smaller scale, they probably won't need to go enterprise. They'll probably be fine with the free version.
Well,
Uh,
the trick, I mean, it's healthcare data, so PII is very important.
this is fair. Good point. Fair
Uh,
point. So the way it would work is like it's an annual spend of CD. Like you actually just pay as you go. So actually, like right now with Dremio, you can just turn on enterprise. Those features turn on, and you just pay as you go for those CDUs.
mm-hmm.
The like that number that you got from GBT, like the 100,000. That's if you buy in bulk.
Uh-huh.
And you get a discount when you buy in bulk.
Yeah.
So it'll be cheaper if they were to buy a big purchase, and then uh, basically they'll pay less for each of those consumption units as they draw down. But again, in those early stages, if they want those enterprise features, they can just turn on and only pay for what they use, which is only going to be used as the computers run. So
Right.
Dremio, and then using Dremio's auto scaling features and
Yeah.
Dremio's performance, sometimes that can still be much more minimal than it would have been on some other platform. So
Fair
it
enough.
won't necessarily
That's what
be 100,000.
that's what well, I'm thinking it would be more like 10 or less, or if
Yeah,
that's even conceivable. Is that
yeah. And then again, if
uh,
they buy, let's say they bought let's say they did like $100,000 worth of DCUs, Dremio consumption units up front, doesn't necessarily mean they have to use them all up within a year. I'm pretty sure
mm-hmm.
those roll over. So,
Oh, that's
um,
interesting.
yeah. So I mean, I double check on that specific map, but I'm pretty sure that's just, you buy them and you have them.
Yeah.
Basically you'll never pay more than what you use. Like again,
Mm-hmm.
you can prepay, and you
Mm-hmm.
get that there's advantages to prepaying,
Yeah.
but it's not forced. You can literally just turn on the knob and get a bill.
I mean, the normal way to do something like that is to start out under one model and then decide if it really works and get an estimate of what it's really going to cost you and then
Yeah,
work it
it's
out.
like
Like
it's like
that's
for
all.
me, like a lot of personal services, I'll start off with a monthly subscription, and then I'll
Yeah,
move over to the annual billing for the discounted price.
absolutely right. So cool. Thanks again.
Mm-hmm.
Hope you come back. And
Of
so
course, no problem.
my request would be for maybe a talk that's focused on data ingestion,
Okay.
if that's something that you could do, or you might even
Uh,
have some podcasts already out there.
yes. I have some meetings next couple weeks
Hmm.
with some interesting startups that might be able to add to that story. So
Oh,
I will see what happens when I talk to the startups, if maybe they would like to come and do a joint talk.
oh,
um
awesome.
but I will have to have those meetings first
Okay.
and see what the story is, as far as like the Dremio and other platform love.
Yes. Well, I think in months when I'm talking about things like this anyway, and we all know what month this is, so no
Yeah.
rush.
No,
Just
yeah, yeah.
in
It'll
the,
probably be February, March.
medium term future, it would be that would be my pick if I had a say in it. So
Okay,
thanks
yeah,
a lot. Yeah.
no problem. I will definitely keep that in mind. And Sandeep, I see your hand up.
Hey, sorry. I just
No,
wanted
it's all
to
good.
have a quick understand. So essentially, Dremio is like Databricks, but with the ETL embedded inside. Instead of going and hand coding ETL inside the Databricks notebooks or a package code. Uh,
Yeah, it's. I mean, that you could think of it that way. Like they're both platforms that want to center your data gravity around your data lake. So like Dremio connects to all sorts of different data sources, but ideal world, we'd like you to put the majority of your data on your data lake. That's going to be where it's going to perform the best. Um,
Say that again,
but
sorry. Majority of the time
so
you would want the data to be in the data lake, you
data
see.
lake, yeah, that'd be ideal world. But the difference is Databricks, you kind of have to have your data in the data lake. So the idea
Right.
is like
Yeah,
you set up Databricks, you have
yeah.
your Databricks file system, and you have to kind of use the data there, and you're using all that Spark and Photon compute, and you have to kind of work with Delta Lake tables. Like you don't have
So you
you
have
know
the benefit of being going to the authoritative source, and also at the same time
yeah
you want to have
the
build a more business oriented architecture. You would then have
yeah
built.
try to be flexible, so that way like we advocate for what we like to call an open lake house. So the
Right.
idea being that like you are still operating from your data lake, so you still have this data warehouse like experience on your data lake, but you're not trapped there. Like you're not trapped in the Dremio world. Dremio is just a tool that gives you reach for your data where it is, and allows you to kind of take on a lot of those use cases, but you're not married to a particular data format. We work really well with Apache Iceberg, but we also read Delta Lake. And you know, we work with different object storage. Like we work with a lot of different paradigms, so that way we are open to wherever you're at, instead of saying, hey, you need to kind of migrate to sort of our way of doing
And
things.
I'm assuming the performance is going to be the best with having the data lake in the Dremio itself, right? Instead
Well,
of going,
nothing's ever inside of Dremio. So Dremio, so even like, so basically, the data lake, you would have your own data lake like AWS or ADLS, and Dremio connects to it.
understood.
But
I'm talking about not from the
but
physics perspective.
yes, your ideal world Apache Iceberg tables on your data lake. That's going to be
So
or
it's not a Hive meta store. It's something else.
correct. You'd be using Apache Iceberg. We query Hive tables. We do support Hive tables, and we perform just fine on those. Probably better than most other tools that query Hive. But it's like the tip of the iceberg, I would say. Well, no pun intended. Would be
I got it.
Apache Iceberg. Yeah, Apache Iceberg tables on object storage are going to be sort of where
Okay,
you're
got
going to
it.
get the just like the chef's kisses performance.
Mhm. All right. Thank you so much. Really, really appreciate this talk. Very, very informative. And
No problem. I always love coming down to TPDEG, and I look forward to seeing you guys again in the next year. So you guys all have a happy holidays, and thank you guys all very much. Thank you, Joe, for letting me do this talk as part of TPDEG, and I'll see you all soon.
Awesome. Thank you much.